Okay, continuing on calculator skill 3, this is example 2. Again, noticeable, we have a table, but there's no equation anywhere. So usually in this kind of problem, they're going to give you a table and they're going to ask you what's happening somewhere later on in that table. And sometimes you can detect a pattern and keep it going and find that answer. And that's definitely a way to solve this. However, going to your calculator is a better bet because sometimes the data is not exact, or it's a real world data, so the points don't line up exactly. So somewhere in the problem, usually, not always, it's also going to either tell you linear, which this one does, or it's going to tell you quadratic. Sorry, this pen doesn't work. Or exponential. Okay, it's one of those three: linear, quadratic, exponential. Sometimes it tells you and sometimes it doesn't. So in Algebra 1, we studied all three. Linear is a line, quadratic is that U-shaped curve, and exponential is the growth or decay model. Okay, so one of these two. All right, in this particular one, it tells us it's linear. I saved us some time. I've already typed this into the listen spreadsheet. So I'm going to put my blue box right after the data. Okay, then I'm going to do two different things here. I'm going to show you some new other skills. So first of all, like we did before, menu, statistics, stat calculations, and number 3, mx plus b, x, and y, and then come down here and click OK. And I have to scroll up a little bit on this one because it was kind of a long list. Here's my M and here's my B. Now these are some kind of crazy looking decimals. So if I was to write this equation, it would be a whole bunch of decimals. But what we just did, the nice thing is if I hit the home button, I can come over here to the graph. Okay, I'm going to come down here to the graph and click on this little icon. And when I do, my calculator goes to F2. It goes to the second equation. I'm not sure exactly why it does this, but if you hit the up arrow key, it's already typed that equation in for you. And so now that equation is in the calculator, I can hit enter. So now my line is in there. The calculator created a line that goes through these points. And then it's going to ask me about some prediction or something that's happening in the future. Okay, and notice it says best prediction or about, almost. Some of the answers on these questions are not going to be exact. It's going to be estimated, but it's going to be very close. So what they want to know is right here. I said they want to know something later in the table. They want to know what's happening with 1,500 people visiting the website. So 1,500 visits. So they want to know what is the output. So menu, trace, graph trace. And then I type in 1,500, enter, and the output is 83.44. So here it just says 83. Again, that's why it says best prediction. It's not going to be exact. And let me give you one more look at why this isn't exact. So if I'm here, I have my, I've entered my data. I can also hit home, and I can go to this purple or pinkish looking graph, and it takes all the data I have in there and it just spreads it out in space. Then if I click here, I can change this to the x-axis, and then it kind of organizes my data upon the x-axis. Then I can come over here and I click on this and I click Y. Now I can see my data and I can see that it's a straight line. Okay, and if I hit menu, analyze, and I run that regression, same thing we were doing before with stat calculation and linear, it'll show me the line that goes through these points, but not all of these points are perfectly on that line. See, this one's down a little bit because this is collected data. So it's running the best line, the best fit line through those points. All right, let's look at the next example. Okay. Again, the graph shows the purchase of a gift shop of purchasing X small flags in a gift shop if the flags are equally priced. Based on the information, which ordered pair represents an additional point on the graph. So again, they gave us some data here. They gave us some points. They didn't exactly tell us what they are, but we can look on the graph. This is 1 and 5, 2 and 9, 3 and 13, and 4 and 17. So I have a table. 1, 2, 3, and 4. Oh, that was ugly. There we go. There we go. 5, 9, 13, 17. And then it says an additional point on the graph. So it wants to know what's the output of 5? What's the output of 8? What's the output of 6? And 7. Ooh, that got really ugly, didn't it? We'll just put 7 over here. So once again, home, new document, save changes, no. Add a list in spreadsheets, X, Y. I'm typing in this table I created. 1, 2, 3, 4. If they give you points, it might be on the graph like this. They didn't put it in a table. They didn't write out the ordered pairs, but it's still a list of data. You just have to compile it. 9, 13, and 17. Enter. Menu, statistics, stat calculations, linear regression. We already know it's a line. We can see it's a line right here. If you can see it's a line, you automatically know it's a line. Click OK. When you do that, it puts it into the graph. So when you hit the home button and we come down here to the graph, it goes to F2. You have to hit the up arrow key and then click enter. There's the line. So I want to know what's happening at 5. Menu, trace, graph trace. 5 is 21. Here it says 5 and 19. So that's out. Then let's see what's happening at 8. 8 outputs 33. 8 does not output 34. 6 outputs 25. 6 outputs 24, not the same. 7 outputs 29. 7 outputs 29. There's your answer. Now, you could keep drawing out this graph and plotting these points until you get to one of these. That's exactly the same thing. And that's exactly what the calculator is doing for you. It's calculating how far over and how far up it's going. It's putting that slope to it. All right, I have one more example I want to do for you. On your quiz, I'm not going to put this on there because I don't really want to spend time going over it in Desmos all the way, but the one for the line, if you forgot how to do that in Desmos, you can go back and watch example 1. But this one is a little bit different. It's a table, no equation anywhere. Okay, it says based on the table, what will be the population of mice at the end of 8 months? So once again, they want to know what's happening later on in this table. Now, you can detect the pattern and keep the table going. 4, 5, 6, 7, and 8. And when you get down to 8, the output will be the answer. Or you can use the calculator. Now, this one doesn't say anywhere, it doesn't say it's a line, it doesn't say it's a quadratic, and it doesn't say it's an exponential. So home, new document, save changes, no. Add a listen spreadsheet. Again, X and Y have to go at the top. That's the most missed thing on this one, is you guys forget to put the X and the Y at the top. Okay, they gave me 1, 0 through 4. Okay, I put my data in. If I don't know it's a line, I don't see a line on a graph, it doesn't tell me if it's linear, quadratic, or exponential, then my next step is to click the home button and go to the pink or the purple. I have to come down here, I have to click this to the x-axis, I have to click this to the y-axis. And then I look at the shape and I can see it's that curve. It's not the full U, it's just a curve. So this is exponential growth. So menu, I probably want to go, well, I can do it from here. Menu, analyze, regression. And this time I'm going to go to exponential. Okay, there's quadratic and there's linear. It could be either one of these three. And show exponential. And then there's the equation, y equals 6 times 2 to the x power. I'm going to come back here. If I click up here, I can come back to the spreadsheet, and I want to go menu, stat calculations. And then again, I'm looking here, it says exponential regression. Okay, there's quadratic and there's linear. Those are the three we've studied this year. So if I hit exponential, again, this is the X column. The Y, we called the X and the Y. Okay. Now, the reason I like to do it here is because that puts it in the graph for me. So when I go home into the graph, it goes to F2. I have to hit the up arrow key. There, it's put it into the equation for me, so I can hit enter. So here's my graph. Now I can find out what's happening at 5, 6, 7, and actually the only one they're looking for is 8. So menu, trace, graph trace, input 8, output 1,536. There's your answer, 1,536. Again, sometimes this might say prediction, about, approximately, close to. On this kind of problem, you'll see that kind of language sometimes. Sometimes it's exact like this one, but sometimes it's just going to be like 1,500 maybe here, and they rounded it. Okay, here's the one for you to try on your own. So you should have went home, new document, save changes, no, add a list in spreadsheets. 2, oops, I put 2 there instead of X. X, Y. Okay, so again, they gave me a table, no equation. If there's no equation to type in the graph, you have to type it in here, statistics, stat calculations, linear regression, X, Y, okay. Then home, we go to the graph, up arrow key, click enter, and it's asking what happens when we do 9 washes. So menu, trace, graph trace, 9, enter. The output is 234. 234.